Okay, so we got number 51. A person can jump a maximum horizontal distance. By the way, if you want to get maximum horizontal distance, you got to jump at a 45-degree angle. That's the angle that's going to give you maximum range. But they give us that angle, and we're told on the Earth, this person's maximum range is 3 meters. You know, that's the x displacement, 3 meters on the Earth. Now, if this person, so what do they say here? What would be this person's maximum range on the moon where gravity is 1/6 of what it is on the Earth? So on the Earth, gravity is g. On the moon, gravity is g over 6. So with this info, we can figure out how far the person's jump would take him on the moon. So, you know, on the moon, even if you never took a physics class, I mean, you could probably guess that on the moon, if this person did the exact same jump, he's going to go, whoa, and he's going to go farther, right? Now, what's the reason he's going to go farther? Is the velocity any different? Nope. The velocity is the same. It's the exact same jump. It's the exact same jump. And, you know, if you break this into x and y, just, you know, be thorough. Here's x component, here's y component, vx, vy. Up here we got vx, vy. There's no difference. I mean, the reason he goes farther, it has nothing to do with the velocity itself. What does it have to do with? What does it have? The fact that he goes farther horizontally, you know, this x right here, the x on the moon is going to be greater than the x on the Earth. What's the reason for that? It has to do with what? Gravity. It has to do with gravity. And then what does gravity cause to be different? What's going to be the difference? Well, the gravity is an acceleration, but this dude is going to have more time in the air. The fact that gravity is weaker allows the guy, you know, what do they use in basketball? Hang time. I mean, this would be incredible hang time, you know, because gravity's not pushing him down as hard. So to solve this question, basically what we got to do is figure out how time on the Earth, so I'll put T sub E, how does time on the Earth compare with time on the moon? Like time in the air, right? Time in the air. Okay, so to do this, we're going to focus on the y direction, okay? We're going to use the y direction, which makes sense because which way does gravity act? Gravity's in the y. Okay, so what I like to do is solve for time up. So for a situation like this, if you can solve for the time up, then how do you find the total time? Then you just double it, because time up is always the same as time down. Now what's nice about this maximum height up here? At the very tippy top, we know that Vy is what? 0, which we can use. Okay, so looking at the third motion equation, Vy final equals Vy initial plus gt. So what is Vy final? If the top is our final, what's Vy up there? 0. There is no y velocity at the top. So what we end up getting is we get t equals negative Vy initial over g, but g is also negative, so that cancels. So the time to the maximum height is Vy initial over g. So what's the total time going to be? The total time in the air, we have to what? We would have to double it, right? Multiplied by 2. So this is an equation for time in the air, right? The total time in the air. Going from the Earth to the moon, what changes? Gravity. So we go from having g to g over 6. So what happens if you replace g with g over 6? What happens if you replace that? Then what happens to time? It becomes what? How much bigger? 6 times bigger. So basically, time on the moon is 6 times the time on the Earth. right? The time in the air will be 6 times greater. Does that make sense? So this equation right here is what allowed us to figure that out. If you replace gravity with gravity over 6, then the time will become 6 times bigger, right? Now, if the time in the air is 6 times bigger, what's the equation for x here? For any horizontal displacement, what's the equation? Vx times t. Did Vx change at all? Nope. But what happened to our time? 6 times greater. So what's the answer going to be? The horizontal displacement on the moon is going to be 6 times greater the horizontal displacement on the Earth. So you go 3 times 6, which is 18. The horizontal displacement on the moon would be 18 meters.